heat conduction through a plane wall. I'm considering a wall which is made up of homogeneous material through which a heat is flowing. Let L be the thickness of this wall, A is the area of cross section of this wall, and T1 is a high temperature face side of this wall, and T2 is a lower temperature face of another side of this wall. So T1 I'm considering as a higher temperature region of face one side of this wall, and T2 is a lower side temperature which has a temperature lower than T1, which is I'm considered as a phase 2 of this wall, where K is the thermal conductivity of this wall. We know the general equation of heat flow in a Cartesian coordinates given by dou square T upon dou x square plus dou square T upon dou y square plus dou square T upon dou z square plus Qs upon K is equals to 1 upon alpha dot T upon, यहाँ पे मुझे x y z तीनों डायरेक्शन में मुझे हीट कंडीशन इक्वेशंस दिया हुआ है इन टर्म्स ऑफ कार्टेशियन कोऑर्डिनेट फॉर्म, बट जो मेरा डेरिवेशन है दैट विल बी एप्लीकेबल इन ओनली x डायरेक्शन. यहाँ पे मैंने लिखा है दैट कंसिडर अ प्लेन ऑफ वॉल हैविंग अ or made up of homogeneous material through which a heat is flowing only in one direction, that is x direction. So from this derivation we can say that the dou 2x t upon dou y square plus dou 2t upon dou z square is equals to 0, because the heat flow in only one directional. Under this derivation we can say that since the heat is flow in only one direction, therefore d square of tau t upon dou square y plus dou square t upon dou z square is equals to 0. As per the Fourier's law of heat conduction, we know there is no internal heat generation inside the slab or a body. Since with no internal heat generation, therefore d suffix x upon k is equals to 0. We assume the heat conduction takes place under the steady condition. Steady condition. Therefore we can say dou t upon dou of tau is equals to 0. It means the heat is flowing under the steady condition. So this is my general heat equation in Cartesian coordinates. In this equation I am assuming three assumptions. The first one, the heat is flow in only one direction. यहाँ पे मेरा heat only one direction में flow है, that is a x direction. So heat flow in y direction and heat flow in z direction will be 0. Second assumptions, there is a no internal heat generated, means यहाँ पे अंदर कोई heat generate नहीं हो रहा, therefore dqs upon k is equals to 0. And third, I am assume that this heat conduction जो मेरा heat flow हो रहा है that will be under the steady state, means dot t upon dot tau, this is tau is equals to 0. Now I am putting all three value in this equation, like I am considering equation number 1. Therefore equation 1 will be dou square t upon dou x square plus this becomes 0 plus qx upon k also 0 is equals to 1 upon alpha into 0. Therefore dot square t upon dou x square is equals to 0. Now I'm integrating this with respect to x, because इसमें दो बार डाउ स्क्वायर है, तो वी कैन से आई एम इंटीग्रेटिंग 2 times. So by integrating above equation, जब हम इसको इंटीग्रेट करेंगे तो वी कैन फाइंड डॉट टी अपॉन डॉ एक्स इज इक्वल्स टू C1, बिकॉज यहाँ पे सेकेंड ऑर्डर इंटीग्रेशन मुझे लगेगा, तो मैंने इसको जस्ट 1 टाइम इंटीग्रेट किया. नाउ अगेन दिस इक्वेशन को मैं अगेन इंटीग्रेट करता हूँ. देयरफॉर नाउ अगेन इंटीग्रेटिंग above equation, therefore dot t is equals to C1 of dx. Now integrating, the integration of dot t is equals to integration of C1 x dou x. This become t and this become C1 x plus C2. So this is my equation number 2. C1 and C2 are the constant, तो हम इसका वैल्यू फाइंड करते हैं. Therefore from this slab we can say, we know when the x is equals to 0, then t become t1. Second, x is equals to when it will be L. यहाँ पे मेरा x2 equal like L, therefore t become t2. So basically मैंने यहाँ पे बाउंड्री कंडीशन अप्लाई किया. आई एम अप्लाइंग बाउंड्री कंडीशन. जब भी मेरा x इज इक्वल्स टू 0 है तो मेरा टेम्परेचर विल बी T1, और जब भी मेरा x2 इज इक्वल्स टू L है, यहाँ पे मेरा डिस्टेंस विल बी L, देन टेम्परेचर विल बी T2. तो ये मेरा बाउंड्री कंडीशन हो गया. अब ये वैल्यू को मैं इसमें सब्स्टिट्यूट कर देता हूँ. लाइक द फर्स्ट वन, व्हेन आई एम पुटिंग t इज इक्वल्स टू T1, देयरफॉर x इज इक्वल्स टू 0. यहाँ पे मैं x ही रखता हूँ फॉर बेटर के लिए, एंड दिस बिकम 1 एज इट इज. सो दिस बिकम 0 प्लस C2, तो वी कैन से C2 इज इक्वल्स टू T1. Now I am applying another boundary condition, that is x is equals to L, therefore t is equals to T2. So I got T2 is equals to C1 into L plus C2. Therefore we can say from this equation C1 is equals to T2 minus T1 upon L, because we know the value of C2 is equals to T1. Therefore C1 का मुझे मिल गया. Now I am putting constant 1 and constant 2 in the main equation. The main equation are t is equals to C1 x plus C2. This is my main equation जब मैंने इसको डेरिवेट किया था. Therefore it become t is equals to, what is the value of C1? T2 minus of T1 upon L into x plus C2 is equals to T1. So from this equation we can say that the temperature difference across the wall is linear, and it is independent of the thermal conductivity of material. बिकॉज यहाँ पे हमारा k है ही नहीं, ओनली क्या है, टेम्परेचर डिफरेंस. द टेम्परेचर डिफरेंस अक्रॉस द वॉल इज अ लीनियर, इट इज इंडिपेंडेंट ऑन द थर्मल कंडक्टिविटी ऑफ मटेरियल. we know as per the Fourier's law of equation, that is q is equals to minus ka dt by dx. ये हमने लास्ट डेरिवेशन में सॉल्व किया था. dt अपॉन dx इज इक्वल्स टू डी बाई ऑफ dx एंड t का वैल्यू पुट कर देते हैं हम d2 माइनस t1 इंटू एक्स प्लस t1 अंडर द मेन ब्रैकेट. Therefore this divide by l. Therefore this become t2 minus of t1 upon l because derivative of x is 1 and this become 0. Therefore dt by dx हो जाएगा हमारा t2 minus of t1 upon l. Therefore q is equals to minus k into a. I am putting this value in equation number this, that is 4 minus q into a into t2 minus t1 upon l. Therefore q is equals to, मैं माइनस को अंदर ले रहा हूँ, therefore q into a t1 minus t2 upon l. So this is called the heat flowing through a wall in a unidirectional or in a x direction. I think you know one another term, that is R of th in a conductions. It is called as a thermal resistance to heat conduction. We know thermal resistance of a body during a conduction is equals to L upon Ka. If I am writing this equation in terms of Q, then Q become what? L upon K है, therefore can I write T1 minus T2 whole divided by this L. जब भी मैं इसको नीचे लूँगा it become K. Therefore Q is equals to T1 minus T2 upon RTH of conduction. So we can say that the heat flowing through a body is equals to T1 minus T2 upon thermal resistance of a body in a conduction. Now I am just writing here where RTH is equals to thermal resistance to the heat conduction. For the numerical purpose आपको R of TH of conduction is equals to L upon Ka and Q is equals to minus Ka T2 minus of T1 upon L, or sometime Q is equals to T1 minus T2 upon R of TH conduction. ये 3 फॉर्मूलेज आपको याद होने चाहिए. आप इजीली न्यूमेरिकल सॉल्व कर सकते हो.